Now let's do an application of exponential equations. Here is a formula for compound interest. We see that A equals P times the quantity 1 plus R over N to the NT. Now, depending on where you get this formula, the letters may look a little different. If you open up different textbooks, they may change a little bit, or if you're using it with the formula sheet or maybe in some finance application, sometimes the letters are different. So let's talk about what each letter represents. A will be the amount in the account at time t. P is the amount in the account at the beginning. Sometimes we say this is the initial amount. We're talking about compound interest, so we make one deposit and we let it grow. So sometimes you might also say this is like your deposit. And then we have an R. R right here is the interest rate. Okay, and we're going to see the interest will be calculated multiple times a year. We'll get to how we find that out in just a second. But R is our interest rate that's going to be calculated multiple times. And we're always going to move the decimal place 2 places. So if you have like 4%, you're going to rewrite that as 0.04. Because in our calculation, we want to be able to use decimals. Okay, and then we have N. Notice N is in 2 places. N is the number of times interest is calculated per year. You might also see this written as N is the number of times interest is compounded per year. And just to kind of give you a little bit of information, if you're talking about monthly, if interest is calculated every month or compounded monthly, then N is 12. If N is calculated weekly, if the number of times interest is compounded is weekly, so compounded weekly would be N equal 52. Okay, and then we have one letter I haven't addressed yet. So we have this T right here. T is the time in years, must be in years. If you were doing a problem that's in months, then you're going to have to make sure you divide by 12. Okay, so A is the amount in the account at time T. P is our deposit, or how much we have at the beginning of the account. R is the interest rate we're going to use. N is the number of times interest is calculated per year. And T is the time in years. So here we have an example. How long will it take to have $22,000 in an account earning 2.13% interest per year, compounded monthly, if we made an initial deposit of $18,000? So take just a moment and read it again yourself. Okay, so hopefully you've read it again. Then we're going to go through and look at each piece. I'm just going to write the letters we are looking for, or that we know over here on the side. A, P, R, N, and T. So let's just go piece by piece and dissect this problem. How long will it take? So is that A, P, R, N, or T? Remember, our question tells us what our variable is, which one we're looking for. So how long deals with time, right? So we are looking for time. That's the question we're trying to answer. How long will it take to have $22,000? So $22,000, is that what I initially deposit, or is that what I want in the account at the end? Well, that's how much I want in the account at the end when I'm done. A will be $22,000. Okay, then we just go piece by piece. In an account earning 2.13% interest per year. Okay, I'll stop that part. We'll get to the rest in a second. 2.13% interest. So that's going to be related to my R. But remember, I'm going to have to change the way it's written. So 2.13%, I'm not going to use that in my calculation. I'm going to move my decimal place over 2 places. So I'm going to take it where it is. It's in between the 2 and the 1, and I'm going to go 1, 2. So my new decimal will be here. So I will have 0.0213. That's the number I'm going to use. Okay, then per year compounded monthly. So compounded monthly, that's going to be the N. And monthly means it's calculated 12 times per year. Okay, and then it says if we made an initial deposit of $18,000. So made an initial deposit of $18,000. So that's how much I put in at the beginning. That is the p-value. So this is $18,000. So again, take just a moment and read it again one more time. How long will it take? So that's what I'm looking for. To have $22,000 in the account. That's how much I want in the future. And we're looking for how long it takes, looking for time. And my account earns 2.13% interest. So that's my R. Compounded monthly, so N is 12. And we made an initial deposit of $18,000. Okay, so hopefully you can figure out where all the pieces came from. I'm going to erase this. So we're going to set this up. We know A equals P times 1 plus R over N to the NT. So we're just going to fill in each piece. 22,000 equals 18,000 times 1 plus R. So we use 0.0213 divided by N. N is 12. And my power is N times T. So 12 is N, and my T, I don't know what it is. I'm going to call it T. So I'm going to solve this equation. Okay, so you may be wondering why this is in the section called Exponential Equations. Believe it or not, this is an exponential equation. 1 plus 0.0213 divided by 12, this piece right here is your base. And your 12 times T is your power. So even though it may not look quite like the exponential equations you've dealt with before, this is definitely exponential. This is a base raised to a power with the variable. Okay, so we want to get the variable T all by itself. So it's the power. So we're eventually going to have to do something with this. But the first thing we should do is try to isolate this whole term. So the first thing I'm going to do, I'm going to divide both sides by my 18,000. So that will cancel. Okay, let's scroll down just a bit. So I'm going to have 22,000 divided by 18,000 equals 1 plus 0.0213 over 12 to the 12 times T. Now, I'm going to simplify a bit. These zeros will cancel right here. So I really have 22 over 18. So 22 over 18. Well, both of those are divisible by 2. So divide them by 2. 22 divided by 2 is 11. 18 divided by 2 is 9. So I get 11 ninths equals 1 plus 0.0213 over 12 to the 12t. You may be tempted to put this in a calculator right now. Don't. Just keep it for now. We're going to put the calculator in all at once. Okay, so we need to solve for this t. So we're going to take a log of both sides. We are not multiplying by log. We are applying an operator, an operation of log. Log of 11 ninths equals log of this whole thing. Okay, and why do we use a log? Well, we know that if we have log base b of m to some power p, we can move this power into the front. It can be multiplied by that logarithm, kind of almost like a coefficient. Sometimes it's a variable, so it may not look like a coefficient, but it's always a product. So this equals p times log base b of m. So I'm going to take this power, this 12t, I'm going to multiply it in the front of that logarithm. So I have log of 11 over 9 equals 12t times log of 1 plus 0.0213 over 12. Okay, I'm solving for t, right? So this t right here is what I would like to get all by itself. So I'm dividing by the numbers that are multiplied here. So I'm going to divide first by this log of 1 plus 0.0213 over 12. You may not like it, but that is just a number. Okay, so when I do that, this is going to cancel. And then I will have 12t on this side. So we'll have log of 11 over 9 divided by log of 1 plus 0.0213 over 12. Now, I still want t by itself, so I still have to take care of that 12, right? So I'm going to divide by 12, and here I'm going to divide by 12. So it's on the bottom here as well. So those will cancel. So you end up with t equals log 11 over 9 divided by 12 times log of 1 plus 0.0213 over 12. And then you type this in a calculator. So you have to hit the log button on your calculator. Okay, probably a set of parentheses will open. Do 11 divided by 9, close parentheses, equals. Okay, that gives you the numerator. Then you're going to do divided by, open a big set of parentheses, do 12 times, hit your log button again, probably a set of parentheses opens, do 1 plus 0.0213 divided by 12, close parentheses, equals. Looks like we get t is approximately 9.42954. And we can round this. We can say approximately 9.4 years. Okay, but let's actually be a little more specific. I'm going to go over here to a little more room over here. So we have 9 years, obviously, and then we say, well, 0.42952 or 0.43 years. If you multiply that by 12 months, what do we get? We end up with approximately 5.15, and so this is months. Okay, so it will take about 9 years and 5 months to earn that $22,000.